Welcome to the Napari MM3 tutorial. Here we will analyze some experimental data that came from the mother machine. First thing we want to do is change our command line to our experimental data directory. Now we want to activate our environment. And now we can launch Napari. First thing we're going to do is convert our Nikon file into a TIFF, into a series of TIFFs. Great, and it automatically infers the data here. We're only going to do the first 3 FOVs in the first 50 frames just to speed things up a bit. We have some convenient settings. Reset numbering just resets the numbering of the FOVs. Great. This is our data. Here it's just showing the fluorescence channel. Next step is to split up our traps into their own separate sub-TIFFs. So again, it infers the number of FOVs. And you can see here the traps, and we can specify the width of any given trap, the separation of any given trap. You can also specify the image source. So if you got the data from a script, or if you got it from Nikon Elements, or if you simply generated some TIFFs yourself, you can select the appropriate setting. Great. Now we are going to mark different channels based on their contents. Green means that it contains bacteria. Red means that it does not contain anything. Blue means that it contains means that it is to be used as a reference empty. In other words, so these define what it means to be in the background. We also compute the autocorrelation. These are the numbers above each trap. The cross-correlation threshold is simply the threshold at which it thinks that a given trap is empty. If it's above this threshold, it thinks that it's empty. If it's below this threshold, it thinks that it does contain bacteria. So for each FOV, we want to select some empty channels to subtract background from. This looks good. Okay, we're just going to go through every FOV and perform this. Thankfully, this goes by pretty fast. Cool, we're done. Now we're just going to subtract off the backgrounds. Alignment pad is sort of complicated to explain, but the general idea is that the bigger the number, the slower it is, but the less error prone it will be. 10 usually works pretty well. We don't have a loading bar for this one, so you can just look at the terminal. Great, so we're done here. Now we're going to run the Otsu segmentation algorithm. We can play with the settings a little bit. Great, but to be honest, this looks pretty reasonable. So we'll probably just go ahead and run it, and for the sake of variety, we won't display the result here. Cool, looks like it's done. Finally, we're going to track lineages. This tells us which cells are daughters and which ones are mothers. We found that these settings would require too much fiddling typically. And cool. This looks pretty good. so we've successfully analyzed our data. Now, if you have fluorescence data, you're going to want to go ahead and subtract not only the phase contrast images, but also the fluorescence. We've switched the mode into fluorescence. The algorithm's a little different, and we've set the plane to our second plane. Cool, it's finished. Now we're going to run the color script. Colors is our fluorescence analysis script. Cool, looks like it's done. We have a number of other widgets you can use. You can refer to their documentation in the GitHub. All right, and to conclude, let's take a look at the final folder structure. We have our TIFFs. These are just the ones that came out of our script. And now we have the analysis. Cell data is where all of the data for our cell is contained. This is everything from the fluorescence data to the lineages. These are stored as pickle files. You can open them with Python. And of course we have the different TIFFs, intermediate TIFFs that were generated. And we have our training directory, and we have our segmentation directory where all our segmented cells live. And we have our training directory where any cells that we manually annotated with the annotate tool go. All right, great. So that's everything we have for this short introduction. For additional documentation, you can refer to the GitHub. And if you run into any problems, please feel free to file a bug. All of that is open access. Thank you.